Hi everyone. Can you guys write in the chat if you guys could hear me?
Walaikum Assalam, miss. Yes, miss, we can hear you.
Okay.
Hello.
Assalamu alaikum. Okay, I'm just sharing my screen and then we'll start.
Salam. Yes.
Wa alaikum assalam. Can everyone see my screen?
Yes.
Okay.
Yes,
Yes.
miss.
Okay. So assalamu alaikum everyone. My name is Aisha
And my name is Aizah.
and today we will discuss data communication and we're going to look at different key concepts. We're going to look at what's important and we're going to look at some different aspects of what data communication is and how it relates to CCNA. So I want to start off with my introduction. My name is Aisha, and for the past 4 to 5 years, I have been enhancing with technology skills. I've done multiple courses. I've done graphic designing. I've done web development. I've done AI. I've done Python, App Studio, and I've also taught in my own platform. I've taught a couple of students for web development myself, and I really love IT and I really love art, and I really love writing, reading, and everything else. So that's a bit about me. I love technology. I love art. And yeah, let's move on to Aizah.
Okay, guys. So my name is Aizah Khan. I'm a 12-year-old girl who has been doing IT for the past 3 years. I'm really looking forward to enhance my IT skills, and I can't wait to be your assistant teacher for today. Okay. So let's move on. So, what is data networking, and why is it so essential? So, data networking is what is data networking? So, what data networking is, it's basically the process, of connecting different devices with each other, okay? So, connecting two or more devices with each other so they can share information and receive information and gather resources, okay? So, imagine it like this. Imagine a group of computers linked together, allowing users to send emails, browse the internet, or access shared files and printers. These are only a few of the things that it can do. It can do also many, many more things. So without data networking, the internet and most technologies that we basically rely on these days, it wouldn't really work. It's so data networking is basically like the backbone of communication in modern businesses, okay?
Now let's look at discovering the world of data networking. Now, whenever you guys see a building, you guys might be thinking, oh, that building looks amazing. It's so beautiful. It's so tall and everything. But have you guys ever thought about what's actually happening inside the building? So here are a few examples of some buildings. I'll just quickly tell you guys which building's which. I live in Australia, by the way. So this is a very famous building in Australia and in Western Australia and also Australia altogether. And this is a building in New Zealand. Okay, it's Spark. This is Rio Tinto. This is Spark. This is you guys might have seen this building. It's the Etihad building and it's in Abu Dhabi and United Arab Emirates. And by the way, I have been to New Zealand before and I was born in UAE. So yeah, I've sort of in a way I have been to all these places. Anyways, let's look at data networking inside a building. So these designs are just beautiful about their looks. There's so much into it. Like they have different data networking devices, such as a switch, a router, and we have a firewall, and there are different cables, servers, and devices that actually work together to share information and they make your communication easier. For example, if my friend is in floor 1, okay, and वो मुझे floor 20 में कुछ send करें, they're sending me something in floor 20, I'm receiving that in 20 milliseconds. That's so fast. Like back in the olden days, it would have taken like 2 hours to send something. That's how cool and so amazing data networking is. Now, these buildings have millions and not millions, but hundreds of networking devices that connect shared data and they work extremely smoothly and they're so much more secure. Now, these devices include a switch connects end hosts such as a laptop, a PC, Okay, and a router is a device that connects different networks. We'll talk more about these devices later, but right now I just wanted you guys to get a bit of an idea of what these relate to inside a building. I'm gonna do the first 5 to 10 slides, and then Isa's gonna do the next 5 slides. Okay, I'll quickly remove the annotation. Okay, now let's look at a communication room. Okay, now by the way, as I said before, this device over here, as you can see, is a switch. Okay, this device is a switch, and this switch connects to end host. And end hosts include a server, a printer, a laptop, a wireless access controller, and these are all devices that cannot connect to one another. What that means is that, for example, if I have a printer, I cannot directly connect my printer to another printer, can I? Which is why we have a device called a switch that connects all these end devices. These are called end devices. End devices are basically devices that cannot connect to any end host. Now, each floor has 2 communication rooms, okay? And either COM1 or COM2. And these communication rooms have different data networking devices, such as a switch, we have a router, we have a firewall, we have a wireless access controller, we have access points, okay? And these devices connect to, laptops, PCs, printers, wireless, as all these different things that I just said. So they are 2 rooms. It's called a communication room in every building. You'll see it in a Ethelsat building, a Spark building, any building in Pakistan. Every single building, a data communicator that has data communication running through has this sort of setup. Now we're going to look at data flow within a building. What really happens within a building? Before I continue, I'll quickly give you guys a very quick example. Now, I have talked about this before, but let me just say it again. Let's say your boss is at floor 1. Okay, they're at floor 1. They're in this building over here. This part of the building. Now, you're in floor 20. Okay, you're on floor 20. Let's say I work in floor 20. That's where I am. That's where my office is, and the boss's office is in floor 1. Now, the thing is, their office is in floor 1, and they're sending me a work file. They're sending me information. They're giving me my assignment to do so that I can do it for my work. Okay, and they're sending it from floor 1 to floor 20 to all the floors. Now, how much time does that normally take? It takes 20 milliseconds, which is the normal time. It's less than a second. That's how vast and how much we've actually progressed throughout the years. Before, it used to take so much time. But now you can make communication is built so much easier that data flows so easily within a building. And that makes communication and sending resources early easier. For example, when your boss is sending you a file, it's making communication extremely easy and extremely more beneficial. And this is because every single building has advanced networking systems, okay? And that facilitate effortless data flow between floors within the building. Now, each building normally has like 20 to 15 floors, or maybe even more. It depends how tall the building is. Let's say this building has 25 floors, okay? And this building has 15 floors. Now, from floor 1 to floor 20, it's sending all that data so quickly. That's because of secure data transfer. Now, I'm not going to go into too much depth because we have a lot to cover, and this might take 2 hours. So do keep in mind, we will have a break after 10 minutes. Now let's look at practical perspective. Now I have already given you an example of Ethelsat building. Now the iconic Ethelsat building in Abu Dhabi it has a very beautiful design. Okay, let's say it has 15 floors. Let's say, okay, I'm just giving you an example. Of course, it has maybe, I don't really know, but let's say it has even more floors, anything else. Now each floor will accommodate like 100 to 50 people. Because in a building, you need many, many different people to look at each and everything. For example, some people might have a role for system administrator. Some people might have a role for administrative administrator. I mean, there are different roles that contribute to different jobs. Okay. Let me quickly see what you guys have written in the chat. Oh, okay. Well, okay. Let's go down. Now, these individuals depend on these robotic communications. This basically means, all the virtual communications such as a switch. These are, by the way, this is how a switch looks like. It does look a bit boring, but each of these ports have 12 ports, and we will look at it further on. Okay, now this is how a switch looks like, and there are multiple switches there are like 100 switches. I'm just saying 100, but there might be more. Okay, in one building. Okay, one entire building. Now, there's so many switches, so many routers, and everything needs care because everyone's communicating with each other. Okay, and this is because this is ensuring smooth operations and efficient teamwork across all levels. So basically, everyone is sending all the information in. This is like the example I gave you guys earlier for the boss, and how the boss is sending me some information, sending me a work file. So that's a bit of a practical perspective. Let's move on further. So Isa will now explain what a main control room is.
Okay, guys. So as you guys can see, we have a building over here, right? This Rio Tinto building on the side. So this is going to be my example that I'm going to use. So in every building, we always have a MCR, which means a main control room. So what this main control room is used for is so all the switches, all the switches that we have, you will learn about these on later on the slides about the networking devices. But all of the switches that the end devices are connected to, all of the end devices are connected to switches. So all of the switches are in the MCR, the main control room. So this setup allows IT administrators to monitor, manage, and troubleshoot. So you can troubleshoot. The administrators are able to do all of these things. And
And
yeah.
a MCR is basically a room where there's like a big router, okay, or anything. It's like a place where you can access the entire building's connections, which basically means if there's an issue that has come up, let's say someone's hacked the building or anything, because of this one room, you can access the entire building's network. You can access all the switches on each floor. You can access all the routers on each floor. You can access everything, which is why it's so important to have at least one MCR room, also known as a main control room. Because of this main control room, the boss or anyone, whoever is like administratively accessing this room, they can access everything, which basically means, let's say, one of the employees, they accidentally delete an important file, and they're trying to figure out which employee deleted that file. They can go into this main control room. I'll quickly annotate, and let's say, let me go here. Okay, let's say this is the main control room. Okay, this one over here. Okay, and this main control room, when you access it, you can access the entire building switches, all the routers, every single critical information that you need. Now, this is a very good security feature because if there's any issue that actually comes up, you guys could go to the MCR and then you could have the whole building set up out for you. Isa will now explain some networking devices, and you guys will be looking at a firewall, you guys will be looking at a router in detail, you guys will be looking at a switch. So I'm gonna hand the microphone to Isa now.
Okay, guys. So when we're going to be talking, before we talk about the networking devices, I just want to show you guys. Can you guys see behind these little logos that I just put on? Well, I didn't put these on for design. These actually mean something. So can you guys see this circle over here? This is a router. This isn't how it looks like in real life, but this is how we represent a router. So these are the networking devices, okay? So you won't always have the name underneath it. So you will be having to like able to, recognize it just by the logo that I see this is a router, this is a switch, and this is a firewall, and so on. Okay, so now let's look further into the networking devices. So starting off from switch. So can you guys see this gray thing over here? Yeah? Okay, so see this gray thing? This is a switch. So this is how a switch looks like. And you guys can you guys see this black, like these little black holes? So what these are, we call these ports. Okay, so you know how Aisha already told you a bit before how the end devices are connected to switches. Yeah, so how are they connected? So when they're connected through a cable, when they have a cable, that cable is going to be connected to this port. Okay, so I have my PC over here, and this is the latest PC that I could find. It's the best PC. So this PC is going to be connected to this port with a cable. Okay. So switches, let me just explain one more thing. Have you guys heard of LAN? So what LAN is, it stands for local area network. So that basically means there are two things. There's LAN and WAN. So local area network is when you're like in talking locally to, for example, I want to talk to Aisha, right? Aisha, for pretend she's not here, okay? Aisha's in that house next door to me, okay? She's in my neighbor's house, yeah. So if she can talk to me, but that's locally, okay? That's LAN. And what WAN is basically talking over a wide area network. I'm guessing that not all of you are from Australia and some of you are in a different place. That is a wide area network. It's basically in the name, wide area network, like talking to a school, across the country, or house, wide. So the reason why I told you guys this concept is so you guys can understand this. Switches are used inside a LAN, not in a WAN, just in the local area network, okay? So all the end devices are connected to that. And moving on to firewall. Now, firewall is one of my favorite networking devices. I love explaining firewall a lot, and I like it a lot. So firewall is pretty simple actually. So a firewall is like a shield. I'm not sure if you guys have heard of Minecraft, but if you guys have, like in Minecraft, if there's a monster, you need a shield. You can use a shield, right? That could protect you a bit from arrows or skeletons or something. So so the firewall is like that shield. It doesn't. So if there's a hacker, I have a hacker. Okay, this is the hacker. It's a very weird looking hacker, right? So this hacker is trying to steal my data. This hacker wants to take my very important information and steal it. And this is not acceptable. So what the firewall will do, it will drop that packet. So you know how we have mail? Mail is delivered to our house. So just like that, we have packets. In the technology world, we have packets. So packets are delivered to the people in the networking way. So the firewall, if that packet is not authorized, the firewall will drop it. It's a shield, so it doesn't allow any unwanted pests or people. Now moving on to router. A router is what a router is, I talked about switches, I talked about end devices, which are it's a way of saying devices. So now all the switches, where are the switches connected to, right? I said that the switches are only in a LAN. So then how is it supposed to go in the wide area network so it can reach the cloud, right? So all the switches are connected to a router. So first I have the PCs. The PCs are connected to the switch. Then the switch is connected to the router. And then the router is connected to the either a firewall if you want to add security or the cloud, the internet. So the router is used in the wide area network. All the switches are connected to it. And that's basically a bit about the router. So let's move on.
Now let's look at the backbone of modern communication. Data network helps people and devices in a building stay connected, which basically means it allows communication to be reliable and more secure. Now, in this way, you guys could share information, you guys could work together, your boss is sending you something or whatever. It's all coming through because of these main devices. I'll quickly go to annotate. And these main devices are a switch. As Aizah has already explained what a switch, router, and firewall is. You guys don't know what a wireless controller is or a access point. We will discuss this further on. But let's just look at these three main devices right now. Now, the main devices that are used in data networking are switches. The switches connect devices like computers, printers, and everything else on the same floor. Okay, it can also be in different floors. It doesn't necessarily have to be on the same floor. And it also connects another device that is used for creating a network is a router. Now, a router sends data from one network to another network. For example, if I have a building, if I go back real quick, let's go back. if let's say I have my Spark building, okay? Let's go back to the Spark building. Yeah, here. Now, what I mean is, if I'm sending a file, okay, let's say a business, let's say the boss over here wants to send a work file to the boss over here, to Intel. How are they going to do so? They're going to do this because of a router. A router is a device that sends information. By the way, it's a wide area network, okay, comes into a wide area network device, and it's going to send info from this router over here, okay, it will go to the cloud. The router sends info to the cloud, which a cloud is an internet, of course. And after the internet, it will go to the router in this building. So that's how it works. I'm so sorry. The diagrams are a bit, confusing, but let's just deal with it and go on. Now that we talked about what switches, routers, and firewalls are, I mean, I haven't really talked about firewalls, but Aizah's already talked about firewalls, and she's talked about how they protect the network from hackers and viruses. Now, wireless controllers actually manage Wi-Fi connections. You guys don't necessarily have to know what wireless controllers and access points actually do, because they aren't really relevant too much. But these three devices, switches, routers, and firewalls, are extremely important, and these are like the backbone of how a network actually gets created. An access point, I'll just say it anyways, but an access point provides Wi-Fi in different areas of a building. Okay, and these devices actually work together to keep data moving safely and quickly. And this is basically why our networks today are created, because of these three main devices. And these devices also come in handy, and they're also why the internet actually flows properly. Now, Isa will explain some of the different certifications, then we'll have a quick quiz.
Okay, and guys, before that, can someone please tell me if they have any questions or if they didn't understand anything so far? Just tell me, guys, unmute yourself and tell me if you guys
Or you
have
guys
any
can write it in the
questions.
chat.
Yeah.
No? Okay.
Okay. So over here, since we're talking about since we're talking about data networking basically comes in like CCNA, right? So I'm not sure if you guys have heard of CCNA, but CCNA, CCNP, CCIE. So what these are certifications that you can work very hard for. It's like an exam, and if you pass that exam, this will help you a lot and a lot of later on. So we have three levels. So I know you guys are seeing four because there's a specialist one, but the specialist one basically comes in the CCNA. It's about like looking into the routers, switches, and all the wireless things. Yeah. So there's basically only three. We have the associate level, the professional level, and the expert level. These are the different levels that they are. So these are for these. So I have a question for you guys. So here's a little question. Since you guys this is a certification, I told you guys this. Now I want to give you guys a little question. So which certification is the hardest one to achieve? Let me go back. So over here, these are your three options: the associate level, the professional level, and the expert level. Can you guys write in the comment section which one you think is the hardest one? So I'm going to wait for you guys' answers. I want to know which one you think is the hardest one, the associate level, the professional level, or the expert level.
By the way, these are all exams. So CCNA is an exam, CCNP is an exam, CCIE is an exam, and each of these exams take time, okay, to, I'm not gonna, I think I'm gonna say the answer, which is why I'm gonna keep my mouth shut, because I was about to say the answer.
Okay, so I'm gonna reveal the answer in 5, 4, 3, 2, 1. Okay, so unfortunately, no one's answer was correct. It is CCNA. Now, how is a CCNA? You all must be wondering. Like if we go back, we have the associate level, the professional, like it says professional and expert, and shouldn't the professional and the expert ones be the harder ones? So yes, they are hard, but the associate level, the reason why it is the hardest is because because you have to learn everything from scratch. You don't know anything, okay? For the CCNP, everything's harder, so it's advanced. So it gets more and more advanced on the way. So the CCNA is the hardest because you don't know anything. You don't have any background information. You need to learn all of it.
Now, guys, you guys are correct. Many of you guys did say expert level. It is technically correct, but if you're thinking about it in a different way, technically CCNA is the hardest because you're actually having to build all your information and everything else, and you're trying to understand each and every concept from scratch. Now, the thing is, CCNP and CCIE is like it's the same thing, but it just in more depth. Let's say we're learning about a router. It's in more depth of a router. What's happening inside a router? What's going on inside? How do you configure? It's a bit, I mean, to be honest, we're doing configurations for routers and everything else in CCNA. But CCNP is an extreme, it's in more depth, and CCIE, it's in even more depth. So yes, you guys were correct. Expert level, obviously, CCIE is harder, but technical wise, CCNA is the hardest because you guys have to build your every
Knowledge,
knowledge
and you
and
have to learn
everything else.
everything from scratch.
Yeah. Now we're gonna look at end devices.
Okay, guys, so I'm going to be talking about what are end devices. So, end devices are, we have talked about this a bit. So, just in case if you guys haven't, like, don't really know so far what an end device is, an end device basically what it is. Can you guys see these phones and laptops, PCs? You know the day-to-day devices that we use phones, we use tablets, PCs, so on. There are more and more devices. But instead of keep on saying whenever you want to classify like a word to classify all of these into one, that's end device. So it's basically a one word that means all of these. So instead of having to say a mobile, PC, laptop, tablet, so on, and all the other devices, you can just say end devices. It covers all of it. It's that simple.
By the way, guys, the class is going to be for 2 hours, I think. So we will have a 10 minutes break after a couple of slides because there are 45 slides and I think it's going to take 2 hours. There's 50 minutes left to this meeting. So we'll just see. Okay, now we're going to look at what are intermediate devices. Now, intermediate devices is more on the networking side, and it's devices that connect end devices, okay? And they're actually the main reasons we have, our networks and everything else because look, end devices are what connect to switches. But if we're talking about networks in general, it's because of these three main devices. Now, these devices facilitate communication and they ensure data reaches the right place. Now, what are these devices? Which ones are there? Obviously, it's the router, the router basically the router connects different networks together, which is why it's an intermediate device. A switch, on the other hand, connects end hosts together. It connects end devices, and a firewall provides security features and it makes sure that there's no attackers or any other wrong person coming inside the network. Okay, so we have already discussed about this, which is why I'm not going to discuss too much on this. But yeah, that's a bit of a very basic summary of what end devices are and intermediate devices are. By the way, do also keep in mind, end devices are devices that cannot connect to any other host. And a host is an example of a PC, laptop, mobile phone, anything else. That basically, for example, when I gave you guys that example of a printer trying to connect with a printer, it cannot directly connect to it, right? You need a different device. And that different device is a switch, which is an intermediate device. Okay.
Now let's look at two roles that classify you into two different jobs.
Now we have the system administrator and the network administrator. Aizah will explain the network administrator and I will explain the system administrator. So for the system, and by the way, we do have a quick trick question that's going to come up. So yeah, just keep in mind and try to like understand it as much as possible. Now, when we're talking about a system administrator, they manage end devices like, computers, servers, and other devices. And remember, by the way, I want to give you guys some examples of what they do, but these roles are extremely complex. And I'm just giving you guys the most basic examples I have found. Okay, so now what they do, they just make sure that the end devices are working perfectly. Okay, they ensure that these devices are secure, everything's everything's okay with them. Okay, they're up to date. By up to date, for example, a system administrator also gives updates. For example, whenever you get an update from your laptop telling you to update your laptop, to go to Windows, they'll just update your laptop in general to go to this thing website and just update it or anything. Whenever you get a notification on your phone, that's because of a system administrator, because they ensure your devices are up to date, they're functioning properly, there's no issue for the users. Users is when, like, yeah, it's basically the people who are using, the devices. By the way, am I speaking too fast? Because me and Isa do tend to speak too fast. So if
Yeah.
anyone can just confirm, we don't mind speaking slowly. Okay, so they also examples are setting up a new employee's computer, managing email servers or databases, troubleshooting problems on a desktop. So these are some examples. Now let's look at a network administrator.
So a network administrator, so what does it manage? So what the network administrator basically does, we have all of the intermediate devices, right? Like the routers, switches, so on, firewalls and everything. We talked about that. And we also talked about how these intermediate devices are connected to the end devices, as Aisha just said before talking about the system administrator, that end devices cannot connect directly to each other. They must have a intermediate device in the middle of that. So the role, so what is their role? So basically what it is, it we use these devices, it's just that so it can all run smoothly, right? So the reason why me and you and everyone, we're all talking so greatly and so smoothly without any issue, it's all because of this. So a few of the things that it also does is, other things that it does just in case if an issue or something else happens, it configures a router. So this is how it runs, everything runs so smoothly. It configures a router to handle internet traffic. It's setting up switches to connect multiple devices and monitoring and securing network traffic.
Now, guys, we do have a 10-minute break. You guys could have a quick 10-minute break and then we'll continue. So let me just look at the time. Okay, it's 2:44 for you guys. So we'll come back in just 5 minutes. Okay. So I'll see you guys in 2:49. By the way, we will have a question later on. It's more related to system administrator and network administrator. So you guys could quickly have a 10-minute break, and then after 10 minutes, we will come back. I mean, sorry, I gave you guys the time for 5 minutes by mistake. It's 2:44 for you guys to come back in 2:55. What are you doing? Why'd you wave? I don't scoff. Okay,
So everyone, are you guys back? Just comment, we're here. Yep.
Yes.
okay.
Okay. Okay. So, if so, we're gonna do a little challenge that Aisha told you about.
Now, guys, which of the two? Look, there are like four roles over here. Okay, there's like a network administrator, there's a system administrator, we have an IT support technician, cybersecurity specialist. Now, out of these four roles, which of these four roles does data networking slash CCNA fall in?
So, guys, we did cover this. So, which of the four roles? So, which one of them? Which of the two does that does CCNA like the data
Something like that.
networking fall in? So, please just write your answers in the comment section. Okay. Okay. Yeah. Okay. So, okay, now we're going to be revealing the answers.
Excuse me for a second. Okay, so some of you guys did say A, and some of you guys said A and B. So that was like, yeah, like, okay. Okay, I'll tell you guys actually, I'm not gonna tell you guys the answer. We'll press on each one, and then you guys will find the answer. Okay. By the way, for two of them, they do fall in data networking. I'm not gonna say which two, but for CCNA itself, it's one. Okay. So,
Okay,
okay,
let's reveal the answers, guys.
okay, now we're gonna press on the bottom ones first, and then we'll go on the top. So yeah, so ICT, you guys did not do this answer, so I'm not going to discuss this too much. But yeah, obviously it's not going to be this because this is out of the scope of CCNA.
Yeah, so no one did
And you know,
C.
you guys did not do this, which is good. And let's look at cybersecurity specialist. This is a whole different field, and it's out of the scope of CCNA again. Now let's see which of the two. Maybe these two are connected. We don't know.
Okay, guys, so let's look at these two, starting off with B, the system administrator. Oops, wrong one. Okay, guys, so it does, it was kind of my fault. I did say two, but it does kind of fall inside of it.
The thing is, data networking itself falls in system administrator and network administrator. But if you guys did notice, I wrote slash CCNA. The thing is, this is a bit confusing because even when I was looking in like learning CCNA myself and looking at data networking, I did think that, system administrator does fall into CCNA. But no, that's because CCNA itself falls into network administrator because it's more on the intermediate devices, which such as routers, switches, firewalls. It focuses on routers, switches, and firewalls, which are intermediate devices. And as we have discussed before, network administrator focuses on intermediate devices, which is why system administrators is wrong, but it does fall into data networking, but it's not does not fall into CCNA itself. So some of you guys are technically correct, but because I said in the question that slash CCNA, some of you guys are wrong, but most of you guys did answer A, which is correct.
So, guys, that was kind of also my fault. I did mistakenly say two. So two. Okay, now network administrator. So it is network administrator so as a CCNA student, you're learning to become a network administrator. So actually, you guys are actually like network administrator right now. You guys are focusing on intermediate devices and network connectivity.
Now, if I go back real quick, I'll just quickly tell you guys why this is the answer. So remember how we discussed about this? and we were looking at this and everything. Yes, we did not really specify which one CCNA, but the thing is CCNA is more about network administrator because it focuses on intermediate devices. Now, this was a bit of a trick question because you guys did have some background information because we just discussed it. You guys didn't really know too much about which one are we specifically talking about. But the thing is, we did give you guys a hint because it's in this whole presentation, we haven't been talking about PCs at all. We have been talking about it, but we haven't been deeply talking about it. We haven't deeply talked about servers. We haven't deeply talked about any of the end host. We have deeply talked about switches. We have deeply talked about routers, firewalls, and everything else. Okay, now we're on to the OSI layers. Now this is extremely vast, okay, and it's a bit simple if I'm going to quickly explain it. So the OSI layer is the open system interconnection model, and it has 7 different layers. Now in these seven different layers, as you can see, we have 7 different layers. Okay, we have, as you can see, I'll quickly draw it. We have, let's say, I'll quickly give you guys an example of what's like the issue of why it was created. Then I'll further on explain what it is. Because if I explain why was it created first, I think you guys will have a better understanding. So let's say back in the old days before this was created, you have a Linux computer. Okay, this is your Linux computer. And your friend has a Windows computer. Now, the problem was back in the old days, okay? This was back in 1969, before it was actually officially created, okay? The problem was if I have a Linux computer and my friend has a Windows computer, I could not directly chat with them or send them information. Why? Because each operating system had their own standards. They had their own set of configuration. They had their own set of rules. So let's say Windows had their own rules, they had their own configuration set up. And the problem was if I wanted to talk to my friend which has Windows, which is out of the scope of Linux, I could not. For example, if I have a different friend and if they have a Linux also, yes, I could talk to them because they have Linux. But the thing is, if I'm talking to someone who has a different operating system, I could not talk to them back in the old days, which was a major issue. Why? Because there was no standard configuration. There was no standard protocol, which is why OSI was created. Now, OSI, also known as the Open System Interconnection Model, was created in 1970, but it was officially introduced in 1984, and it's been around since 41 years. And of course, it's been updated and everything. Now, here are the layers. We have the physical layer, data link layer, network layer, and transport layer, session layer, presentation layer, application layer. We will explain each of them real quickly, but we'll just look at this real quick. So, okay, and this was created by the ISO, also known as the Organization for Standardization. And it was created so there's one standard protocol, one standard for every single operating system, so they can use one standard, okay, one official standard that the whole world uses, so that everyone can communicate. For example, if my friend has Linux and friend has Linux and I have Windows, okay, or my other friend has Dell or anything, we all can communicate with each other. Okay, this is why OSI was created, because it's like a official standard, okay, so that everyone could communicate. Okay, now let's look at the application layer. Aizah will be doing the session layer to really be explaining to you guys what the session layer is. Now let's look at the application layer. So the application layer is the 7th layer, and it is used for network applications. Okay, now you guys might have looked at, maybe looked or heard, or maybe whenever you guys search something, you guys have seen HTTP or HTTPS. Now this is used for web surfing. Okay, now we have file transfer, we have web surfing, emails, virtual terminals. Application layer is actually used mainly for network applications, which basically means all of these commands, everything in here comes inside it. So file transfer is when it's a protocol that uses FTP, and it's when data exchange. It's like a data exchange protocol, and application layer has different sort of protocols. It has a communication protocol. It has the email transfer protocol. It has remote access protocol. And for example, if I'm sending an email to my friend, I'm doing that by SMTP. If I'm web surfing, I'm doing that by HTTP, or also known as HTTPS. Okay. And also for file transfer, if you're sending a file to your friend, or your boss is sending you something, he is doing that, or she is doing it, whatever, they're doing it by FTP. And here are some other protocols that are used. Obviously, application layer uses much more vast protocols, but these are just some of the basic protocols that are used. Okay, and it is just keep in mind that it's used for network applications such as Chrome, when you're sending something, when you're searching up something, when you're sending an email, okay, or when you're looking up at something. So it's used for all of these basic, configurations. Now let's move on further. Let's look at Let's look at a presentation layer. So a presentation layer is used for three basic functions. Now, its actual presentation layer is a bit complicated, which is why I have broken it down into 3 bits, okay? Now, we have translation, data compression, encryption, and decryption. Okay, I will explain the encryption and decryption. I will explain translation and data compression. So what does it translate? The thing is, the computer itself cannot understand alphabetical or numerical itself code. It understands binary, and binary consists of ones and zeros. You guys might have heard of binary before, but if you guys haven't, binary is basically numbers that are only consist of 1 and 0, and that's what the computer actually understands. It does not understand AG or whatever. For example, if I'm writing my name, Aisha goes to school, it does not understand that. It will what it will actually do, for example, if I'm sending my friend something and I write, hey, what's up? Are you gonna come to school today? The computer itself is going to change it into binary so the computer understands it. Once the computer has understood what you have said, whatever I've said, it will then go to their router switches and everything. Then their computer will access it. It will decrypt that data. That's what encryption and decryption is all about. I'll explain that real quick.
Okay, so guys, looking into encryption and decryption. So what encryption is, and so what encryption basically is, so I have my message to my friend, okay, and it says hello or hi, okay? So my message says hi. So when I'm sending that to my friend, and just so no hacker or anyone tries to steal my message and wants to see, oh, what personal things, or what am I writing to my friend. So what presentation layer does, it encrypts the data, so it basically turns it into binary. So what binary is, can you guys see these numbers, like these ones and zeros? So binary comes in ones and zeros, okay? The 1 represents the network administrator and the 0 represents the host. Okay,
So this is done because after it encrypts it, when it goes to their computer, they will decrypt it, which basically means when it's in binary, it will decrypt it to alphabetical codes so that your friend actually understands. Because obviously we don't really know what 1 and 0 actually means. Now let's look at data compression. So there is 2 types of data compression ways. There's lossy and lossless. It's a bit of a confusing topic, but I'll just quickly tell you guys what it is in simple form. So data compression is when, let's say you have a file, you're sending your friend a file that's 5 Mbps. It will compress it into 2 Mbps. That's what it basically is. Now, lossy data compresses and reduces the file size, but permanently removing some data. That's what lossy is. Lossless, it's when it does not remove any data, your data is secure, nothing gets lost, but it does say take some more time. Okay, now let's look at the session layer.
okay guys, so looking into the session layer, so what session layer basically does is that I'm going to be highlighting the main points that session layer does, okay?
Hold on.
Okay, guys. So the main points that session layer does is the first thing that the first one of the main things that it does, it controls the dialogue, okay? So it controls the dialogue between the applications. The second main thing, it establishes and maintains and terminates connections. So when I'm talking to Fatima, my friend, so first what session layer will do, it will establish the connection. So if I want to talk to her, in order to talk, there should be some connection, right? I need to first establish the connection, and it also terminates the connection. So when I'm done talking to her and when I'm not in use, or like when I'm not talking to her, that connection gets terminated, okay? The third main thing that it does is synchronize. So what does it mean by synchronized? What does it do when I say synchronized? So what that basically is, it's over here. So it gives you the option of doing data exchange, like recovery. If in case of like an interruption, what happens? So the synchronize, it will synchronize it. So um it will give you any like
Whenever
the
you
options of
create,
recovery.
the thing is, session layer is whenever you're sending something or anything, it will automatically create a session. And in that session, you can text your friends, you can send something. So that's what a session layer actually does. Now we're gonna move on further, and Isa will explain the next part of. Isa will explain what transport layer is, but I'll be further explaining what UDP and TCP is.
So what the transport layer basically does, the transport layer, the layer 4 of the OSI model, so it basically provides you end-to-end communication. So by doing end-to-end communication, this makes sure you have a no like no you have no unreliable data. All of your data will be reliable. It will do error detection. So it will do error detection, reliable data transfer, and correction. So what Aisha will be explaining, there are two ways that when this transport layer, there are two ways that it gets transported. So it can either get transported in the UDP or TCP. So Aisha will be explaining these two for you.
Okay, now let's look at UDP and TCP. Now, UDP is not reliable at all, and it stands for User Datagram Protocol. TCP, however, uses a three-way handshake, and it takes more time, but it is more reliable. It's also known as Transmission Control Protocol. Now, TCP is normally used when integrity is most important, which basically means if you're sending, let's say your boss is sending you something, and he needs to make sure that that file goes to you, because like it's an extremely important file. Okay, that's when TCP will be used. Yes, it does take more time compared to UDP, but UDP is not reliable. It does not establish a connection. And overall, UDP is not commonly used. It's used whenever, for example, right now, when we're in Zoom, you are using UDP. On the spot, we're using UDP. Why? Because we are establishing a connection, but we're not having to, come back to this meeting every single day, and it's not extremely important. Let's say when we leave the meeting, we'll join again. That's what UDP is. It's normally used for, video calling, it's used for gaming, it's used for voice video streaming. Like for example, video streaming also includes whenever like we're doing a Zoom meeting, whenever you guys have classes, okay? And but UDP is, first of all, it's not reliable at all. UTCP is reliable, which is why it's used in buildings, it's used in more public servers, and UDP is used in public servers, and TCP is not used in public servers. TCP, as I said before, it's used in buildings. It's used when data integrity is crucial, such as web browsing, email, and file transfers. For example, you're sending your teacher your homework, and you need to make sure that homework goes to her, and none of the data gets lost. The thing is, if you're sending it from UDP, let's say it goes from UDP, some of the data, let's say you have a 16-page work file. Some pages of that work file will get lost. Let's say 14 pages are lost, and she only gets 2. Now, the thing is, TCP uses a three-way handshake. It does not say over here, but you guys could search it up. TCP does use a three-way handshake. That's a whole different topic. But because of that, it takes more time, but all of your data gets sent securely. Isa will now explain what a network layer is.
Okay, guys. So moving on to the network layer of the OSI model, which is the layer 3. So the network layer is responsible for routing data. So what I mean by routing data is, so it is basically responsible of showing the data the best route that it should take. So when we're driving to a park, and the GPS will not tell us the longest route, right? It will tell us the best route. Okay, it will give us the best route. So just like this, the network layer recommends the best route for the packets between devices across different networks, so I can go. And it also handles logical addressing through IP address. So a few of the key functions include packet forwarding. So it forwards the packets, routing that I told you guys, and addressing.
By the way, guys, IP is a whole topic itself, but IP is known as Internet Protocol, and it is used in the network layer, and it's used it's like basically an address. Let's say we have our home address, and that address, it's an address itself. Our computer has an IP address. Every single computer in the whole world has an IP address, and an IP address is used to identify your computer. Okay. And that IP address is used in the network layer so that it can send it from source to destination.
So, in other words, an IP address is also a unique logical identifier of your device. Okay, so moving on to data link layer, layer 2 of the OSI model. So, this one Aisha is going to be telling you guys about the data link layer.
So data link layer operates in layer 2 of the OSI model. Remember the OSI model, we're talking about all the other layers. Like we're talking about open system interconnection model. Okay. And it is responsible for node-to-node data transfer. So it's responsible for data transfer. It's responsible for all of these things that I've listed over here. It's responsible for a vast of topics. Okay. Okay, so it also looks at error detection and correction in a local network. It handles the packaging of data into frames. Frames is used in a data link layer. Okay, and it manages access to the physical medium. We will talk about the physical medium after this slide, which is the physical layer slide. So some of the key aspects that it actually does is data framing. What does that mean? It basically frames the data. We haven't talked about frames, but the basic function that actually does is packaging of data into frames. Now it packages raw bits. Are basically like a type of size, okay, and bytes is another size that's a bit more bigger than bits. Okay, so let's say bits, 1 byte is wait 1 minute. 8 bits equals to 1 byte. That's a whole different confusing topic, but right now just look at this. So basically, data framing packages draw bits from the physical layer into frames, and that includes headers and trailers. Addressing, it uses MAC addresses to identify and direct data to the correct device on the local network. Now, if you guys did not know, it's not written over here, but switches you know how the okay, my God, wait, hold on. The switches, hold on, let me put this here. Okay, so for the data link layer, switches work in the data link layer, as you guys could see over here, and it uses MAC addresses, also known as the MAC address table. That's a whole different topic. So MAC addresses are different, and when you're configuring a switch, you guys could also access your MAC address table, and there's error detection and correction. These are more into depth, okay, and they're a bit more confusing, which is why we're going to skip this.
Okay, guys, so now I'm going to be talking about the physical layer. Okay, so let me quickly just grab the highlighter over here. Yeah. Okay, so the physical layer is the first layer of the OSI model. So in this layer, all of the physical connectivities happen. So physical connectivities, I mean the connectivities by the cables that are actually connected by your hand. So it's like in the name, physical connectivity. So yeah, Aisha's going to be telling a bit about this too.
Now, guys, the thing is, we only have 11 minutes left, so which is why we're trying to speed up as much as we can. We do also have a quiz. If I look here, okay, well, let me show you guys. We have a quiz also, but we're gonna have to skip the quiz because we only have 10 minutes left for this meeting, and the teacher did not give me another meeting to go on to. So we do have a quiz which the basic questions such as which layer uses TCP and UDP. We also have a couple of different questions. But because of the time, I'm gonna skip the quiz. Here are the answers, by the way.
Show them the answers.
We'll quickly look at basic configuration. Now, first of all, we're going to look at why configuration is important. And I want to speed up a bit because of time, but I'll try my best to tell you guys all the slides because we do have a good 6 slides left. Now, configuration is necessary to ensure the network devices operate correctly and securely. Configuration is when you assign a task to a device or your switch or router. So configuration is normally done in switches and routers, firewalls, and everything else. So a configuration is when you're setting it's like a couple of commands that you give to a switch. So for example, when you're doing CCNA, you're gonna learn different commands that are used. Okay, and from those commands, you guys could access and you guys could change the host name. We're gonna look at some. You guys could give the configuration some. By doing the configuration, you guys could give the switch or the other interface, okay, some passwords. Okay, you guys could assign it. You guys could create NATs. You guys could create OSPF and other. You guys could apply different protocols. You guys could assign it an IP address. The thing is, when you're by the way, if you guys do CCNA, do look at do use Cisco Packet Tracer. It's a very amazing platform that you guys could use, to practice. And if you guys do so, do remember that switches, routers, and everything else, they do not automatically have an IP address. Yes, you do have to configure it, okay? Which is why configuration is extremely important, because by configuration, you're assigning IP addresses, you're giving it a name, you're connecting it to different computers, okay? Because the thing is, whenever you connect it manually, you have to connect it manually by doing configuration. And you can do that by I'm going to say the configurations. You guys might not understand it, but I will show you guys some basic configurations later on. For example, you have an interface that you have connected it to, and you have a fast internet interface. If you go to interface and you go no shutdown, that's how you make it connected to the router. That's just a very simple example, but it is confusing right now, which is why I'm going to give you guys some very basic configuration methods. For example, we have hostname. I will explain what these are. I'm just going to quickly tell you what we'll cover. We have password configuration. We have how do we configure this password in configurations. Okay, we have enable secret, enable password. Aizah will talk about enable password, and I'll talk about enable secret. Hostname is very easy. Hostname is just basically you're just changing the name. And all you need to write is hostname. It's that easy. Okay, and it's easier to identify and improves management. For example, I have 100 PCs, okay? All right, let's say we have a building, okay? Let's just imagine a building topology. And in that building, you have 100 switches. Now, by doing the configuration, doing enable conft and just writing host name, by doing host name, by the way, enables when you go inside privilege mode. These are different modes. We don't really have too much time to talk about it right now because we have 7 minutes. But configuration mode is when you're inside the config mode, which is where you configure. Okay, and when you're a host name, you're basically assigning a name, okay, to the network device. For example, I have like 100 switches, and if I do not name them, it'll be harder for me to identify. And let's say one of them has an issue, okay. And the thing is, I cannot identify which one's which because they all have the same name, which is a bit of an issue. Which is why when you assign a host name, which most professional companies do so, okay, like every single building, every company, even when you're making your own topology, do change the host name because that's how you can identify your network. You can identify which one's which. For example, you have a switch and router, okay, PC. Do change the host name for everything. So, for example, for a host name, you can change it for normally it's done for. You can change it for your router or your switch, and you can also change it for your firewall. Password configuration is extremely simple. So there's enable password. Enable password is a simple password. Enable secret is another password, but it is more encrypted. Enable secret uses a message digest 5, which is a security method. Okay, and it uses this command message digest 5, and because of this, it is more encrypted. That basically means, let's say I've written Aisha. Okay, that's my password. I've written Aisha. The thing is, if anyone goes to my configuration, they can literally see my password. For example, they go to my computer and they just look at my computer, okay, and they see the password, they can literally see it on hand, okay, because they can just look at what password I've written. For example, I've written Aisha, they can see what I've written, okay, that's a bit of an issue. Now, the thing is, enable secret is not secure at all. Let's say you write your name or anything else, okay, we'll show you guys how it looks like. Okay, as you can see over here, yeah, as you guys can see over here, enable secret, Aisha, done. And for example, I have my password over here. All right, write the password. You guys cannot see the password because whenever you're doing configurations, you cannot directly see the password, but it is happening. Okay. Anyways, this is enable password. Okay, and this is enable secret. Enable secret uses message digest 5, which is and it uses this message digest 5 is what makes it more secure. Basically, it encrypts it. Enable secret does not do any encryption. But enable secret, I'm sorry, my bad. Enable password does not do any encryption, but enable secret does do encryption. Okay, it uses message digest 5. And because of this, whoever's accessing the network, they cannot see what I'm writing, okay? And they cannot, whenever they use the show command, they cannot see what I'm doing, which is more secure and more reliable. Aizah will talk about enable password a bit.
Okay, guys. So enable. So the enable see. Wait, we're doing enable password, right? Yeah. So the enable password command is used, but it's wait, sorry guys. So the enable password command is less secure than enable secret. So this one is the reason why it is less secure. Because it is written in plain text. Okay. So but it does make the password it isn't like you can decrypt it. There are also apps online that you could use.
Yeah, but the thing is, enable password does not use message digest 5, which is a way to encrypt the password. It actually does not use anything. It's just written in plain text, which is a major drawback. Which is why no companies or any proper building, they use enable password. The only thing that they actually use is they actually use enable secret because it being more extremely secure, and because they have like so many switches and so many routers, they need their network to be secure, which is why they use enable secret. Enable password is not commonly used at all, but for practice purposes, people do use it. Now, guys, thank you so much for tuning in. We only have 3 minutes left, and we did try to rush the slides as much as possible. And if you guys can, I'll just quickly copy paste these two links in the chat. If you guys can you guys please leave? We made a form. There's only like 5 questions. So can you guys please leave a review and just tell us if we have to for anything. For example, you guys can write, oh my God, we have given you guys options. For example, the options are we've spoken too fast, we've spoken too slow, we could have changed this, we could have changed that. So if आप लोग रिव्यू दे सकते हैं तो बहुत ज़्यादा हेल्प होगी। और आप लिंक्डइन के अंदर भी मैंने प्रोफाइल बनाई हुई है, तो उसमें से कोई रिव्यू दे सकते हैं तो बहुत मैं हाईली अप्रिशिएटेड होगा। मैं आप लोगों को ये सेंड कर रही हूँ चैट में, और मैं 5 मिनट 2 मिनट बाद के बाद ये आप लोग कॉपी कर लीजिएगा, और ये 2 मिनट के बाद ये मीटिंग एंड हो रही है।
If you guys have, do you guys have any questions? You guys could ask us. If you guys have any questions, please do tell. We would gladly answer that. Okay.
No, it is. I know we've explained, the end of the slides, we have explained in a bit of a confusing way. That's because of the time. But the thing is, just the configuration part, obviously, it's going to be a bit hard. I have given the forms, by the way, guys. So, yeah, thank you so much for tuning in. And this was a very wonderful lecture, and this was our first time doing something like this. So, yeah. And in this lecture, you guys have learned about OSI layers, a bit of enable password and secret, but not too much because, the time was running out. And we looked at what data communication is. We looked at different aspects about how it works in a building. Okay, and I'll quickly review the slides real quick. So wait, is that just right? We talked about the OSI layers, and we also did a bit of a quiz. We looked at system administrator, network administrator. This is a quick, question, and we looked at intermediate devices. We looked at end devices. Next time we're gonna add less slides because there were way too many slides.
Okay, guys. So for the configuration, you guys could also download Cisco Packet Tracer for hands-on practice. You could just watch a few tutorials or videos on YouTube. This would really help because it's better to have hands-on practice. So just download Cisco Packet Tracer and then you guys could practice.
Okay, thank you so much for tuning in. We're gonna leave the meeting right now because it's ending in 40 seconds. Assalamu alaikum. Allah Hafiz.
Bye.
Allah Hafiz.
Allah Hafiz.
Hafiz.